Hi everyone, welcome back to week 4 of programming with Python. My name is Corey and joining me today is Damien.
Hey there everyone.
And we have the rest of our DreamSpace team working in the background to answer any questions that you might have, okay? So please make use of that Q&A section to your right-hand side. Now, again, I am going to emphasize this week to please pause myself and Damien at any stage, okay? That's what the feature is there for. So you can pause us, you can carry on with your code and then unpause us and then we'll just be there where we left off, okay? Now, last week, Damien and Amanda set you a home challenge, and your challenge was to create an app or a program that could convert miles to kilometers. Okay, so actually really useful. Just one thing I want to note is that the formula last week, I just had a typo in it, so it read miles multiplied by 5 divided by 8, but it's actually the opposite way around. Okay, so I'm sorry about that, but I'll show you how we can fix that now in a second. It's not really a big deal. So what I'm going to do is I'm actually going to hop into Jupyter Notebooks and I'm going to start coding out last week's home challenge widgets. So if you want to follow along with me, you can indeed, okay? So the first thing that I like to do actually when I've been given a task or an assignment by a teacher or a lecturer is I actually like to take the task, so like highlight it all, and insert it as a comment in my code, okay? Just so I can keep track of what I'm doing. So I'm going to just paste this in here now and using my hash symbol, I am going to comment them, okay? So now I know that the first thing that I need to do is create a function, okay? And you learned how to do these last week. So I'm just going to actually insert a cell below this so I can start coding out. Okay. To define our function, we use the key words, okay? Define or def, D-E-F or define. And then we name our function. So I'm going to name my function something like miles to kilometers, okay? And don't forget your roundy brackets and your semicolon. Now, when I press enter, everything is going to be indented in, okay? Because within our function, anything that's indented is actually part of that function. So I know the next thing that I need to do, so I'm after creating my function, so I'm just going to get rid of that. The next thing I need to do is ask the user to enter a distance in miles. Okay, so I'm going to do a print statement first, because I'm going to print to the screen. I'm going to say to the user, how many miles did you drive? Let's say, okay? And now I actually need to take a user input, don't I? Okay, so I need a variable first. So I need my miles. And miles is actually going to be the input that the user uses. But I need to be careful here, okay? Because I've said int input, which means that I'm just saying that the user is going to input a whole integer. But if I actually check what the home challenge was, I can see here that you were given a float. Okay, so there's one error in my bug that I've noticed already, okay? So I'm actually going to change int to float because later on we are going to be inputting a float. Now I can get rid of this part because I've done this part now. Next part, then the function needs to convert miles to kilometers using the formula. Okay, not to worry, we know what the formula is. So I'm saying kilometer is going to be my variable, okay? So kilometer is going to be equal to, and we need our brackets here, okay? Because we want our code to do this part first. Whatever miles is multiplied by 8, okay? So that would be where the formula was just a little bit different in the home slide last week. So you're going to multiply by 8. And then whatever miles is multiplied by 8, whatever that answer is, we're going to divide it by 5. And that is our formula and how to convert miles to kilometers. And I just need to do one last thing. I need to actually tell the user how many miles they drove in kilometers. So I'm going to use a print statement for this, and I'm going to say print you drove, and I need a comma because I want to actually add something else to this print statement. So I'm going to add my kilometers here, okay? But one more thing that I'm going to do, because I just like how this reads, is I'm actually going to add another thing to this print statement. So I need another comma, and I'm actually going to add the word or the letters KM, okay? And you'll see why now in a second. So we know there's two parts to the function. There's actually defining the function, and then there's calling the function back. So I'm going to make sure now that I'm outside of my function for this part, okay? And I'm just going to call on the function, which is miles to km. And the beauty of this is, if you look at your home challenge, you had to do it 4 times, okay? So can you imagine having to do out that code, all that code 4 times? This is why functions are great. All I have to do is I can actually just copy and paste my function 4 times. And now I can input all of the miles that I need to input by just doing those simple 4 lines of code, okay? Instead of actually having to redo all of this. So I'm actually going to run this now. I might have errors, that's fine. But let's just run it and see what happens. Okay, how many miles did you drive? And the first one there, Damien, it's 20 miles, isn't it?
20 miles, yeah.
Which is 32 kilometers. What's the next one?
So the next one we had was, sorry there, I've missed that.
No, don't worry, I think 33.
That's right.
Let's try this out. 52.8
and
and
17.2.
This is where our float comes in. Perfect, 27.52 kilometers.
And lastly, 108 miles.
108. 172 kilometers, a long way away.
Yeah,
okay.
Quite a big number.
Now can you see why I added in that little km there? Because if I didn't, it would just say you drove 32. And I wouldn't have that little bit. And look, it's not something that you need to do, but it just reads nicely. Now, I actually do want to try something out, sorry, on a personal level, because I have started doing Couch to 5K. So I only started now, so you're going to have to go easy on me, Damien. But what's mad about the app that I use is that the whole point of it is to run 5 kilometers. So it's supposed to be like 10 weeks of running, and by the end of 10 weeks, you can run 5K. But anytime I log a jog, it logs it in miles, which is so frustrating for me because I'm like, I'm trying to learn if I'm near the 5K, but you're telling me what it is in miles. And I'm not even making this up just for the sake of the webinar. This is actually something that happens to me every single morning. So then I have to go off and have to research what is 2.3 miles in kilometers. So I done it this morning, but I actually didn't research it because I knew we were doing this today. So I'm going to run this and see if I'm near my 5K.
How many miles did you do this morning, Corey?
2.3. Now remember, I only started. I'm only on week 3.
Pretty
so good. I done, drum roll, boop. I done 3.6.
3.6 kilometers, pretty good.
That's actually very good, I think,
yeah,
to be
you're
fair.
Getting there. Well done.
I only started, thank you. So I think just something else I want to highlight here before I move on, everyone, is I done that code and I didn't get any errors. And to be honest, that's not really how coding goes a lot of the time. Like, you will get errors and you will get bugs. And, you know, I knew I was doing this today, so I popped on beforehand and I just practiced it. And when I practiced it, I got like 7 errors. Okay, so I left a comma out. Okay, I put in a plus instead of a comma. I had my formula wrong. I put in int instead of flow. And then I spelled input, intput. Okay, so these are all things that are going to happen when you code. And I used to get so frustrated with myself because I was like, I hate making mistakes and coding is so hard, and it is hard and it is frustrating, but you are going to make mistakes. And to be honest, being able to find your error and fix your bug, there's more learning in that than there is me getting that right in one go. Okay, so please, if you're only learning Python for the first time, stick with it. You're doing absolutely brilliant. Okay, now, what are we doing this week? Okay, so this week is possibly my favorite. Damien's sick of me talking about how much I love what we're doing this week. So this week we're introducing choices in coding. So you might have noticed up until this point so far, our code has just been doing simple step-by-step instructions, okay? It's been following exactly what myself, Damien and Amanda have been telling it to do. But this week, we actually want to introduce the concept of our code being able to make decisions, okay? So for example, imagine you're applying for your driver license online, okay, and you're filling out the form. The first thing that it's probably going to ask you is, what is your age? Because there's no point of you going on then and filling out the whole form if you're not even old enough to drive, okay? So the computer program might ask, what is your age? Because then it can decide whether you can continue or not. And how it does that is that it uses what's called an if else statement, okay? And we actually use if else statements all the time in everyday life, okay? We do them without even noticing. So for example, I might look out the window and I might say, oh, if the queue isn't long outside Dunn's, I might actually run down, or else I'll leave it till later. Okay, in English, we use them all the time. And in coding, they can make us do some amazing things. When we are using if else statements, we use symbols with them as well. Okay, so for example, is their age less than 18 or less than 16? So here are the symbols that we use when we're using our if else statements. We have greater than, we have greater than or equal to, less than or equal to, okay? Then we have my personal favorites. I don't know, Damien, if you have a favorite symbol in coding, but mine is definitely equal to, and not equal to. So right. I don't know if anyone else shares my passion about this, but I always wondered, I was like, why do I love these so much? I honestly couldn't wrap my head around it, but I think it's because we've seen these before, haven't we, Damien, in maths?
Yeah, so we would have used the greater than and less than a lot, and the greater than or less than and equal to might have looked a little bit different when we're using them in our maths copies or whatever, but hopefully we kind of have a little bit of an idea of how they work already.
Exactly. And then with these are new to us, aren't they? These are for Python, these are for coding. So equal to actually means that something is actually equal to. It's not just assigned to something. And then we have our lovely exclamation mark equal to, which is just not equal to. Yeah. So I'm very passionate about them. I love them. And we will
so
see
important them. Too. Like they'll come up so much in your coding as you go on. So we will use the equal to a lot and the not equal to a lot as we go on.
Exactly. We might even get a look at it today. But what Damien's going to do now is Damien's actually going to take you through what these if else statements look like when we're coding.
Okay, guys, I'll just share my screen here. So we're going to look at a couple of examples on how we use these if statements and these else statements to kind of figure out a couple of problems. All right, so just bear in mind, we'll be coming back to this table here, looking at the different symbols and how we're going to need to use them in different questions and different problems. All right, so here is what an if else statement kind of looks like when we get it coded up. All right, so in this problem here, we just have two variables assigned at the start. We've got our first number and our second number, and they're just two random numbers that we're going to use in this problem. So the first thing when we need to make a choice, we need to start with our keyword, which is going to be if or else. There are two keywords at the moment, and we'll have one more before we finish today. Then after our keyword, we'll have our condition. So this is the question that we're asking, or the decision that we need to make. So here we've got if first number is bigger than second number. All right, so we're asking this question, or we're making this decision. So in this example, Corey, maybe you could help me out. Is first number going to be bigger than second number?
Well, the first number is 10 and the second number is 18. So no, it's not going to be bigger than.
Okay, right? Perfect. So here we've got our condition is not correct, where the first number is not bigger than the second number. So this part here, this bit of code that is indented or pushed in, that means it's part of the if statement. And we won't be doing that because this condition is not true, or it doesn't make sense. We won't do this print statement. We won't write that out. Instead, we'll go down to our else part. So because the if bit wasn't true, we go down to the else part and we do that instead. So here it says else, and then we print out second number is bigger than first number, but instead of second number, we'll put in the number 18 because that is what it's assigned to. So 18 is bigger than 10. And this is how we're going to try and use our if and our else statements as best we can to figure out problems. So we'll take a look at a problem now. So we said a little bit, we talked about the driver's license and stuff. So imagine you are applying for a driver's license and you need to fill out a form online. So you're filling out your name and your address, and you got to put in your age. All right, because one of the questions, they'll have to make sure that you're old enough to apply for a driver's license. And when you enter your age, the computer will decide whether you're actually old enough to apply for the license or not. So how are we going to do this? Well, we're going to write a little program that asks the user to enter their age. We will check if the age they enter is greater than or equal to 16, because that's the age you need to be to get a driver's license. And that's kind of like what Corey said. It's like in the real world where we're asking a question, if. So check if the age entered. And then we'll print out. So we'll either say that they are old enough or else they are not old enough. Okay, so I'm going to jump over to my web browser here and we'll go to our Python. But I really did like what Corey did there earlier where she copied the steps. I thought that was a great idea, Corey. So I might do that as well. So we'll put in our steps here and we'll work through these. So I'll just comment these out at the start so that they don't affect our code. So the first thing that we need to do here is we're going to ask the user to enter their age. All right, so print bracket. Please enter your age. And then when we go and we're going to get the age, we'll need to create a variable for age. Corey, I might ask you, should I have this as an integer or a float, do you think?
I think this time it can be an int, can't it?
An int might be good. For age, it'll kind of always be a whole number. So input. We have our two brackets. Okay, so we get the age in. The person enters their age into the computer or into the device they're using. And then we've got to ask the question. So if age is greater than, so Corey, can you remember what age we said you need to be to apply for the driver's license?
16.
So does it need to be greater than 16?
Well, no, it could be greater than or equal to, because you can be 16 to get a license as well.
Yeah, I agree. That's great. So we're going to use our symbol for greater than or equal to 16. And then once we finish our condition, so once we finish the question that we're asking or kind of trying to make the decision, we have to put a colon to show that we're finished with that condition. And then underneath that, we're going to have our print statement, which will be indented, pushed in, print. So if the person is greater than or equal to 16, that means we can say you are old enough to get a license. Okay, so that's the first part. If someone enters their age and they are over 16, it should print out you are old enough to get a license. And if I was to run this here, this program should run pretty well. And if I put in that I am 20 years old, it will tell me that I am old enough to get a license. But what if I put in a number that, sorry, we'll go back up here. What if I put in a number that is less than 16? So I'm only 14 and I'm applying for a license. My computer doesn't run anymore. Corey, you might help me out here. What is happening here? What's the problem?
Well, you've written lines of code to say, you know, what's going to happen if you're greater than or equal to 16, but you haven't said what's going to happen if you're not.
Yeah, exactly right. So we've got to write another couple of lines of code, which are not part of this if statement, because this only takes into account if someone is over 16. So we're going to come back out of that indented part. We don't want to be still indented anymore, and we're going to write another bit of code. Now, Corey, I know you love to just use if statements sometimes. So
I do.
We could write another if statement here and say if the age is less than 16, and then we'd probably cover all the bases. But you're probably better off to use the keyword else, because this takes into account everything else. So we'll write the keyword else and then print you are not old enough to get a license. So here, if we are over 16 and we go in here, we'll print this statement. But if we're not over 16, it will print this part. And we'll just test that out really quickly to make sure it works. So I'll run this. I know that if I put in the age 20, it works. So if I put in the age 14 now, it will tell me that I am not old enough to get a license. All right. So hopefully that makes sense, guys, and we'll keep moving on. But if you need to pause it and you need to take a second to kind of have a quick look over or make sure that it makes sense, make sure that you do pause it and take a break. Right, we'll jump back here. So we're going to look at another example now, Corey. We're going to try and create a little game. So last week we looked at random numbers, and we're going to use that a little bit here. So we're going to get the program to create and remember a random number between 1 and 10. Then we're going to ask the user to guess a random number between 1 and 10. We're going to compare the user's guess with the random number that the code picked. And then if they get the guess right, we'll say that they win. And if they get the guess wrong, we'll say that they lost, and we'll print out the correct number. So we'll try and give this a go together, if that's all right, Corey.
Yep, let's do it. Sounds fun.
Okay, so we'll go back here, and I'm going to paste all this stuff in, and we'll just comment it out. You always do this, Corey, do you?
Yeah, I don't know what it is. I just kind of like having it all in one place instead of having to jump in between different things, making the use out of the comments.
And it's amazing how people do things just a little bit differently. Every person who does coding does things a little bit differently, and there's so many different ways to do all this stuff. Okay, guys, so the first thing that we want to do, we want to get the program to create a random number. So hopefully you remember from the last day that to create a random number, we're going to need to get in a library, all right? And how we get in a library is we use the keyword import, and we're going to import the library called random. And once we have the library imported, that means we can use it. So I'm going to get my random number, and that's going to equal to random.randint. So this gets a random integer, and we're going to get a random integer between 1 and 10. Great. Okay, so now once I have my random number, I'm going to have to look and get the user to input a number. So we might say print, and we'll ask the user to please guess between 1 and 10. And then, so here, Corey, I'm going to need a variable. Is there a variable name that might be good to use here, or?
I'd just go with guess.
Perfect. Guess equals to, and we're going to have an integer input. So now we've got our two numbers. The computer has made up a random number, and we've got the user to guess a number. All right. So now we got to check if they are the same number or not. So we're going to write our if statement. Now, here's your favorite symbol, Corey. How are we going to check this, or what's the?
Well, we're going to want to say, well, if guess, so if whatever the user inputted into guess is equal to the random number.
Perfect. And we use 2 equals. What's the difference between 1 equals to and 2 equals?
Well, with 1 equal sign, we're assigning something, aren't we? We're assigning what's after the equals to the variable, whereas with equals to, we're actually saying that something is the same as.
Yeah.
Is that right? Yeah.
That's a great explanation. Yeah. So here, where we've got 1 equal sign here for the guess, this is saying to the computer that whatever is inputted here, save that to the variable called guess. But when we've got 2 equal signs here, it's checking the number that's stored in guess or saved in guess against the number that's saved in random number and checking if they are the same or not. So it doesn't write over anything, or it doesn't change any of the numbers. It's checking to see if they're the same. So if the random number is the same as the guess number, we'll print out that you win. Okay. Ooh. And then if the numbers are not the same, so we could write it as another if statement, or if the numbers aren't the same, the only other option is that they are not the same. So we can just write an else statement for everything else if we want to. So else print, we'll just print wrong. The number was, and then I'm going to put a comma here, and I'm going to print out the random number so that the user can see what number the computer picked.
Ah, very good.
So we might just try this. We'll run this code and see if it works. So please guess a number. Corey, I'll get you to guess a number there for me.
7.
7.
My fave. Oh.
Sorry, hard luck. So that guess was wrong. The number was the number 2. So the random number that was picked was the number 2. Just one more time. It'll probably be impossible to get it right, but give me one more guess, Corey.
I'm going to go with 5 this time, and I'm feeling
5.
confident. Oh.
No. Okay, so it would be quite hard. So if you wanted to make the game a bit easier, we could make these random numbers smaller. We could get it to pick a random number between 1 and 3 and get the user to pick a random number between 1 and 3, and it might make it a little bit easier to figure out or to get the right answer. But really what we're getting here is we're looking at the if statements and the else statements, and then looking at the symbols that we use for them. Okay. We could even add to this game a little bit. So there's another little add-on that we could do. What if we had more than one choice? So we've got our if statement, and if that's true, we use that. And then if that's not true, everything else is the same. But we've got another kind of keyword that we can use, Corey. You might be able to help us explain it.
Yes, so we have Elif. So this comes into help. So this really helps us when we actually have more than 2 options. So yeah, when we want to keep checking things.
Yeah, so if we have more than 2 choices, so it's not one or the other, if we've got more options available, we can use the keyword Elif, and it gives us more choice. So we might try and put this into our code from there. So we have the same problem. So we're going to get the user to guess a number between 1 and 10. If they get it right, we'll say that they're correct. But if they get it wrong, we're going to see if they guessed that the number was too low or if the number was too high. So we're going to have 3 choices here. They can either be correct, too low, or too high. And to do this, we're going to use this keyword Elif, and we'll put this into our code here. So we'll jump out of this back here. So here, all of this stuff here will be the exact same. All right, if they guess the number correctly, it's going to be a win. I might actually change these numbers back to 10 just so that we have it working. But here, I'm going to get rid of this else statement for a while, and we're going to replace it with an elif. So this is really saying, if the first thing isn't true, or if you didn't do the first part of this if statement, then take a look at this elif statement. All right, so here we're going to see if the number that the person guessed is less than the random number, sorry, or random number. So if the guess number is less than the random number, we're going to print out a little message. Corey, should this be just less than, or should I put in less than or equal to?
I'm not sure. What do you think?
Well, so if guess was to be less than or equal to, then we'd actually have the right answer. So because we're only looking here, we've dealt with if they are equal. So now we only need the less than symbol in this example.
Very good. Okay, that makes a lot of sense.
But it takes a bit of thinking about your code and your numbers to see which symbol needs to go in here. And it is worth giving it a little bit of time.
Definitely.
So we'll just print here, say your guess is too low. And then we might just have one more elif statement where guess is greater than random number. And if the guess is greater than the random number, we'll print out your guess is too high.
This is cool.
Yeah, so we'll just test this and see if it's going to work. So I run this, so I have to guess a number between 1 and 10. So we'll guess 4 this time, and I got it right. Okay, I didn't expect that.
It took me so many times.
Yeah, We'll try it one more. I was hoping to actually get it wrong to see if it works. Oh, this could be a problem.
Here, I'll try. I keep getting
Yeah,
wrong,
go
so
ahead, Corey.
Go on, run it again.
Run it again. What number?
9. Go on, 9. Go for 9. Yeah.
Okay, so here it says your guess is too low, so we must have got it wrong. And if our guess was too low, then the number must have actually just been 10.
10.
So, and that's actually, now that I look at my code, I think I'm missing an S there. I might just run this one more time and see. So if my guess is too high, okay. One more time, we guess 10. So
there might just be, in your last Elif there, there might be just another S.
Yeah, so there could be, so that could have been giving us an error. So if it got down to this Elif statement, it mightn't have actually got to do this part because it didn't know what the number guess was, or GUES was. So we just got to be careful with our syntax and stuff and our typing. But hopefully that makes a bit of sense. We've got our if statement, and then we've got our condition, and then we've got our Elif statements after that if we need them. So if you've only got 2 choices, you won't need the Elif statements. But if you've got more than 2 choices, you might need to put in more conditions or more checks along your code. And you'll need a little bit of this for the home challenge today. So you will need to use Elif statements hopefully for the home challenge. The last thing to do with if and Elif statements that we're going to look at today is sometimes we have to be able to combine 2 conditions. All right, it's not good enough to just say if something is greater, or if something is less than, or if something is equal to. We need to be able to put them together a little bit more. So there are a couple of keywords that we can use for this. So if we had a problem where you had to find out if somebody was a teenager and they had to enter their age into the computer, and we had to decide, is this person a teenager? Well, we could check and see if their age is greater than 12, but then if someone entered an age like 25 or 26, that number is still greater than 12, so it would say that they're a teenager. Or we could say that their age has to be less than 20, because teenagers are less than 20. But then if we entered a number like 8, 8 would be less than 20, so they would also be called a teenager in our program. So we need a way to be able to put these 2 kind of rules together. Corey, you might be able to help me out with these keywords, would you?
Yeah, so we have and we have or. So they can be really, really useful, can't they, when we're coding?
So useful. They can make your code so much shorter and so much easier to kind of read. So we use the words and or when we're writing a condition. So we might just try and quickly write this up before we finish. We'll do one more here.
Sounds good.
We're going to print a quick message. Please enter your age. Then we'll get the user to enter their age. Age equals int input. And we're going pretty quickly through this bit, but hopefully this is all familiar and we're kind of able to kind of get this. So if we're looking to see if someone is a teenager, we're going to get the computer to check if age is greater than 12. So if you're 12, if you're above 12, you're going to be a teenager. So that's 13, 14, 15, 16, 17, 18, 19. But then we need it to stop. So the keyword I would use here, Corey, would be
and.
Yes, great. So we want the age to be less, or the age to be greater than 12, and we want the age to be less than 20.
Now, Damien, just real quickly there, see the way you have if age greater than 12 and age less than 20. Do we have to have that second age in there?
So if we wrote it like this.
Yeah.
Yeah, so we do have to have the second age. So if we use the and keyword or the or keyword, we need to tell the computer exactly what we want. So here we're saying that age has to be greater than 20, but in other programs, you may have more than one variable, or you may be checking different things. It mightn't always just be age. So we have to tell every condition, we have to give it the variable that we're checking against and then the number that we're checking for. Does that make sense?
That makes sense, yeah.
Yeah. So we've got age has to be greater than 20 or greater than 12 and less than 20. And if this happens, we're going to print out you are a teenager. Okay, and then really quickly, we'll just put in an else statement to say, print you are not a teenager. Okay, so if we really quickly run this just to make sure that we're working. Sorry, now did that run? So I might actually have to start my kernel again. So this might take a second. Okay, let's see. No, so we might have to come back to this again, guys, but hopefully the idea makes some sense here, that if the age is greater than 12 and less than 20, it will go in here. So we're asking it, oh, there we go. We're asking it for two conditions. So if I am 16 and I put that in, it will tell me that you are a teenager. And I think it's down here. It's after closing on me. So my kernel seems to be acting up here, but hopefully, guys, we get the idea. Corey, are you happy enough with that?
Yeah, no, that makes a lot of sense. Very happy with it.
Okay.
So it's a lot of fun.
Great. Yeah, good stuff. So I might hand back over to you, Corey, if that's okay.
Yeah, okay. We'll go through what we covered today so far. So well done, everyone. That was amazing work. So what did we learn? We actually covered a lot because we covered conditional statements or if-else statements, okay? And with those, you're able to make choices, okay? So your program is actually able to make choices. Then we looked at our symbols, so our less than and greater than and our equals to signs and how they can be really important in our conditional statements. And then we use the Elif keyword, okay? And Damien explained that we use this when we actually have more than two options. So we don't just have if, else, we might have if, Elif, else, okay? And then finally, we looked at two keywords. We looked at and or, okay? And we learned how these can make our conditions more exact, okay? So, time for your home challenge for next week, and this is to create a math game, okay? So you are going to get the computer to generate two random numbers, okay? And we done that today with one, so remember we had to import the random library, we had to do round int. So you are going to just get the computer to generate two random numbers. Then you are going to multiply the two numbers and save that answer as a variable. You're going to write out the sum of the first, multiplied by the sum of the second, and then ask the user to enter the answer to the sum. Okay? Once all that is done, then you're going to check to see if the user got the sum correct or not. So if the answer is correct, you might print a message like this, well done, you are correct. Or if the answer is wrong, you might say, hard luck, your answer was too low. Okay? And then we printed out the correct answer is 45. So you'll know how to do all of this from what you learned today. So well done, everyone, on an amazing webinar. You're doing absolutely fantastic. So don't forget that all of the files that are that Damien went through today and anything else to do with these Python webinars are all on our aka.ms/homespace files, and you can find everything there. Hope you enjoyed today. So that's all from myself and Damien, and see you next week at the same time. Bye.
Thanks, guys. Bye.